Hello, this is Eduardo Regueta Camero, a student from the Polytechnic of Madrid University in the Master of MCC Rail Mobility Technologies. Today I'm going to talk about software for railway dynamics. First of all, we've got an index, there's an introduction followed by what it is, main softwares, historic evolution and researches, future R&D lines, and conclusions. First of all, we've got the introduction. Okay, softwares for railway dynamics are informatic programs and environments which bring solutions to test and improve current or future designs, saving cost and time. These softwares allow customers to modify mechanical parts like bogies, suspension elements, train models, as well as wheel profiles and along, etc. But let's see how they really work. And this is the what it is part. In this part, we are going to talk about how these software solutions, how these simulations of railway dynamics are done. To do these simulations, there are many complex equations and mathematical systems that have to be taken into account in order to be solved to be able to get these simulations done. So, there are two ways to simulate these problems. The first one is using the method of finite elements, which is based on approximations of partial differential equations, and the second way, which is the use of multibody systems, which are a set of rigid solids connected by joints. This way is based on two mathematical methods to be solved that could be the Gustav Hermel formulation or the Euler method. So, as this is not the scope of this essay, we are going to talk about the main software. Okay, let's talk about the different solutions that are on the market, but only about four because there's many. But we are going to talk about only about these four solutions: Adams, VGrade, Universal Mechanism, Simpac Modules, and Vampire. So let's start with Adams and VGrade. Adams is a multibody system developed by the company Hexagon or MCC software. This product is used by the German company VGrade to bring excellent and innovative solutions to this field of railway dynamics. It allows to simulate the wheel contact, rail wear, which is how much material is removed because of the train rolling, and some other things like stability, comfort, or any kind of railway model. The second software, Universal Mechanism, has two modules: Train, which allows the creation of any train model, and the simulation of its longitudinal dynamics in braking, traction, and idling modes on any railway track configuration. On the other hand, we have a second module, which is Loco, which allows users to create fully parameterized models of vehicles. According to Manchester University benchmarks, is 10 times faster than the competence, and that is possible thanks to the use of symbolic forms of complex models and equations. Well, the third software is Vampire, which is property of the company S&C Levin, a Canadian company, and they assure that this is a really powerful tool, but one of the most affordable at the same time. As well, they talk about how easy it is to use thanks to a 3-day course which led users to obtain advantage enough from Vampire main features. It can also simulate any rail vehicle and its response to measured track geometry. They assure that it's 10 times faster than the analogs, as well as And finally, we've got Simpac. Simpac is a software from Dassault Systems, the French company, and it has 4 rail modules: Simpac Rail, Flexible Track, Rail Wear, and Calcar Contact, which is a third-party add-on to the Simpac universe. These 4 modules allow customers to study any rail-guided system on any track, being able to use different components or flexible tracks. Furthermore, this software is also capable of measuring wheel contact and rail wear, among other options. Let's talk now about the historic evolution and researches. Let's talk more about the researches. There's been many improvements, but some great features that we are going to talk about are 4. We could talk about much more, many others, but let's talk only about four, not to take this longer. These four are the optimal wheel profile for freight cars from the point of view of its stability and wear factor, the ability to simulate vehicle with different wheel profiles on axles running over track with Variant rail profiles, an improved contact data generation, and also an improved accuracy for simulations under dynamically varying conditions. We also have the future R&D lines. Traditional railway systems are still working higher speeds, safer trains, and more comfortable journeys, even with higher frequencies. So, although those RD lines are already a reality, they already exist, these traditional railway systems, there are some technologies like maglev that is used in Western countries, Western Asian countries, sorry. Maybe it's not as extended as traditional railway systems, but they already exist. But they have something in common with new technologies like Hyperloop, which are based on magnetic levitations. So this could be future RD lines in order to achieve better means of transport with higher speeds, for example. And finally, let's talk about the conclusions. Governments have targeted greener and more sustainable cities in the future for a better world, so trains will suit nicely in that plan. Apart from that, there is a constant need for better services, so trains are required to go faster, be safer, and more comfortable. So it's obvious that investment on this field will not stop, and softwares of for railways dynamics will keep improving. So it's a magnificent world that will have many updates in the future. And this is it, all from Eduardo Araguete. So if you've got any kind of question, you can email me. Thank you so much.